Hi. So in this question, we need to find out the trace of a particular given matrix. Uh, particular the operator. So t of fx is defined as x times f dash x minus f of x minus 1. So to solve this problem, we need to start with we can see some pattern by taking 1x and x squared. So our vector space is vector space of polynomial with real coefficient and degree at most n. So suppose we want to see how this transformation is happening for the basis element 1x and x squared. Okay, so what we have, t of 1 is what? X times 0 minus f of minus 1, which is equal to minus 1, right? And minus 1 can be written as minus 1 times 1 plus 0 times x plus 0 times x squared, like that. Similarly, we have t of x is x times f dash x is 1 minus f of x minus 1 is x minus 1, right? And this again gives rise equal to 1. So which is equal to 1 times 1 plus 0 times x plus 0 times x squared. So now we have t of x squared is equal x times 2x minus x minus 1 whole square. That gives rise x square plus 2x minus 1. So we can simply write minus 1 times 1 plus 2 times x plus 1 times x squared, right? Okay, so similarly, if we have t of x cubed, that will be equal x times 3x squared minus x minus 1 whole cube, right? So this will be equal to 3x cubed minus x minus 1 whole cube. So that will be equal 2x cubed plus 3x squared minus 3x minus 1. So from this we can see that transformation matrix. So the transformation T that looks like minus 1 0 0 0 then 1 0 0 0. So what's happening for the higher term, we can just simply write the higher terminal of 0 times x power n. In all these cases 0 times x power n, right? So similarly we have minus 1 2 1 minus 1 minus 3 3 2, right? So what's going to happen for the nth term? So t of xn. So for the t of xn is t of x power n is going to be equal nx power n minus x minus 1 power n. So there will be in the coefficient of x power n will be equal n minus 1, right? So coefficient of x power n will be n minus 1. That we have already seen in the previous pattern. So basically the matrix, so we are interested in the trace of this matrix. We are basically interested in the, so for the nth term, what will we have, what we will get in this in the non-zero in this position is n-1. So basically we're interested to in the trace of this matrix, right? So we are interested in these diagonals, and which you can easily see that so this is, we're not interested in the other values, right? So so the trace of the matrix so the trace of the matrix can now, this is the matrix, so we're interested in the trace. So what's happening, the trace is equal so the trace of the matrix T equal 1 plus 2 plus up to n-1, and there is a -1 term in the first row and first column, right? Okay, so this gives rise to n-1 into n by 2 minus 1. So this is equal n square minus n minus 2 by 2, which is equal n minus 2 times n plus 1 by 2. So this is the trace of this transformation, and this is the correct answer as well. This is the answer, n minus 2 into n plus 1 by 2. Alright, so what we have done in this problem, so given the transformation t of fx equal x times f dash x minus f of x minus 1. So initially we have seen how the transformation is happening with the 1x squared, and from there we have found a pattern that the entries of the matrix, how the entries of the matrices, especially the diagonal entries, so that we found out that it's of this in this form, and then from there we have found the summation of this diagonal element, and which is nothing but the trace of this corresponding matrix. So this is the correct answer for this problem. Alright, thank you.